Welcome to EEL 512, Electronic Circuit Analysis. Chapter 2, Electronic Circuit Analysis, Silicon Controller Rectifier, SCR, Application. Part 3, Evaluate SCR Applications in Power Electronic Circuits. In this part, we are going to analyze SCR circuit, half-wave SCR with RL load. An SCR with an RL load works much like the R load case, still requires forward bias and a gate trigger pulse to turn on. However, the inductor in the load introduces some new effects we'll discuss next. In the positive half cycle, the SCR starts forward biased, but does not conduct immediately. It needs a gate pulse, which is usually applied at a firing angle alpha. When triggered, the SCR turns on and keeps conducting, but because we have an inductor in the load, the current does not match the voltage exactly. It lags behind. This lag means that current can keep flowing even after the voltage has crossed zero, all the way up to an extinction angle beta, where it finally stops when the current falls below the holding current. In the negative half cycle, the SCR is reverse biased, so it blocks the applied voltage. However, from 180 degree to beta, the inductor releases its stored energy and keeps the current flowing in the same direction. Once the inductor has discharged, the current drops to zero. This angle beta, also called the conduction or extinction angle, tells us how long the SCR continues to conduct after it is triggered, taking into account the inductor's energy storage. The inductor stores energy while the SCR is on, which prolongs current flow even after the voltage crosses zero. This makes the output voltage stay active after the half cycle ends, increases the phase difference between voltage and current, and lowers the power factor. To fix this, we add a freewheeling diode. When we add a freewheeling diode, the SCR still turns on with forward bias and a gate pulse, but when the SCR turns off, the diode provides an alternate path for the inductor's current. In the positive half cycle, the SCR is forward biased and triggered at the firing angle alpha. Current starts to flow through the RL load, and the inductor stores energy in its magnetic field while causing the current to lag behind the voltage. When we move into the negative half cycle, the turns off right at the zero crossing or slightly before, due to the natural current fall. However, the inductor still has stored energy, and it tries to maintain the same direction of current flow. Without a diode, this energy could cause a sudden voltage spike, but here, the freewheeling diode provides a safe alternate path. The diode becomes forward biased and allows the current to circulate in a closed loop through the load and inductor, bypassing the SCR entirely. This ensures the energy is released smoothly, preventing abrupt current drops, lowering voltage stress on the SCR, and improving the power factor of the circuit. These PSIM simulation results show the effect of the freewheeling diode. The output current now decays more gradually and smoothly compared to the abrupt drop in the circuit without the diode. Finally, the average output voltage is calculated using this equation, where V sub M is the peak input voltage and alpha is the firing angle. Thank you, and see you in the next video.